Dear students, today's topic is the nature of dielectric materials. So, depending on the energy structures, we can classify the materials into three categories: conductor, dielectric, and semiconductor. And here we have a look on the classification of insulator, semiconductor, and conductor based on its structure. So, in insulators, the energy gap, the forbidden energy gap between the valence band and conduction band is large. That means the electrons in this valence band find it difficult. It needs more energy to move from the valence band to conduction band. But whereas in semiconductor, the band gap is smaller than the insulators. So, if we excite the valence band electrons, they will easily move from the valence band to conduction band. So, valence band electrons are very close to they are very bound to the nucleus, so they cannot freely travel through the materials. So, once these electrons move from the valence band to the conduction band, the electrons are very free to move, so they become more conductive in nature. So, the electron will easily move through the conductor. They become conductors. But in conductors, pure conductors, there is no forbidden energy gap. The valence band and conduction band are merged. So, it does not require, the conductor does not require an external electric field or energy to excite the electrons in the valence band to move from this area to the conduction band. They can easily move from the valence band to the conduction band. So, the conductivity of these materials are very high. So, these are the classification of the materials based on the conductive property. So, in mathematically we can explain this property using a ratio. So, there is a ratio. It states that conduction current to the displacement current, it can mathematically represent as sigma divided by omega epsilon, where sigma is conductivity of medium and epsilon is permittivity of medium and omega is the angular frequency. So, what is the conduction current? So conduction current divided by displacement current. What is the conduction current? Conduction current is the electric current which exists in a conductor when the electron flow in the conductor at a uniform rate. So we have a resistor. If you across the resistor, there is a voltage source. So R is the resistance offered to the flow of current. So the current will flow from the high potential to low potential. This is the conduction current. But whereas the displacement current is the current exists between the plate of parallel plate capacitor is the displacement current. So this is the capacitor, the parallel plate of capacitor. One side is a plus, another side is negative. So if there is the current exists between the plate of this parallel plate capacitor is the displacement current. So note that the conduction current is due to the flow of electrons, whereas the displacement current is due to the displacement of electron in the time varying electric field. So conduction is nothing but the flow of electron, whereas this is nothing but displacement current is nothing but displacement of electron between the plates of the parallel capacitor. So the expression is sigma divided by omega epsilon. And if sigma divided by omega epsilon is greater than 1, this is nothing but the material is very good conductor. If sigma divided by omega epsilon is less than 1, the material is dielectric. Again, we can classify this dielectric material into two classes. So, one is non-polar molecules, another one is polar molecules. Here you can see that a detailed expression of the energy structures of different conductors, different materials. The conductor, there is no forbidden energy gap, whereas in semiconductor, the forbidden energy gap is 1 electron volt, whereas in insulators, it is 5 electron volts. So unless electrons get the 5 electron volts, it cannot move from valence band to conduction band. Here, the 1 electron volt is enough for the electron move from the valence band to the conduction band. Here, see, it is free of electron exchange between valence band to the conduction band. See, if the electron can freely move through the conductor only if it reach in the conduction band. If it is in the valence band is very bounded to the nucleus of the atom. So any atoms in the valence band cannot be part of a conduction band. So again, we can classify the dielectric material into two different. One is a non-polar molecules, another is a polar molecule. So let's discuss about what is non-polar and polar. So non-polar molecule, when molecules share electron equally in a covalent bond, there is a no-net electrical charge across the molecule. So the examples are methane and carbon dioxide. In carbon dioxide, one carbon and 2 oxygen. So when electrons are shared equally, so there is the covalent bond. So these type of molecules are not dipoles. So these molecules do not have any plus and minus. There is no charge, no non-uniform distribution of charges. But when you come to the polar molecule, an example is hydrogen fluoride, where fluorine is more electronegative material. So they will share the electron. But fluorine is more electronegative in nature. So finally, the electron will move away from hydrogen, and so the bond will be like this. There is no uniform sharing of electrons. That means the hydrogen will possess a small positive charge and fluorine will possess a small negative charge. So equal and opposite charges are separated by a very small distance. So this is a dipole. So these are the classification of dielectric materials. So some of the dielectric materials are non-polar and some of the dielectric materials are polar molecules. So this is the end of topic 2.